Shall we do one more example?
Yeah, we can do one more example. But this time I want to make it slightly more interesting.
Okay.
Okay, in the sense, let's say we are going to try and use superposition on a network, but we know measurements across a resistor, but we don't know what the voltage sources are.
Oh, okay. So it's the inverse problem in some sense.
Problem, right?
Okay, okay.
So let's look at that. So problem 11, right? Okay. So I want you to, okay, let me see how best I can describe this circuit, right?
Okay.
So can you just draw like a square with two resistances on each side first?
A square with two resistances on each side. So one vertical, one horizontal in each corner. Can I do it like that?
Yes, exactly.
Okay. So that's an easy way of drawing.
Yeah. Correct.
So I'll have a total of 8 resistors.
Yeah.
Is it like this?
Exactly.
Okay.
Now from these midpoints of that square, you can draw like 2 voltage sources, right, on the horizontal side.
Okay, with the positive being on which side?
So the 2 voltage sources are facing each other. So it's like negative on one side, positive on the other side.
Like this?
Yes, and the other side is the mirror.
Like this?
Yes. Okay.
Okay.
Now similarly for the top and bottom, where you have a
like this?
Yes, but the bottom guy, make it a resistor. That's all.
Oh, I see. So it's not a fully
Okay.
Interesting.
Yeah.
Okay.
So this is the problem that we have.
Okay.
And we have each resistance is 6 ohms.
Okay.
We don't have to deal with different resistances, and every battery is 12 ohms.
Okay. So this is 12 volts.
12 ohms.
12 volts.
12 volts. I'm sorry.
Okay.
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 And so let's just start.
What is our job now to find out?
Actually, okay. So now we are not doing the inverse problem yet. We have to find IA. I mean, through this 6 ohm in the middle.
Okay.
Can you mark that as IA?
Upwards or downwards?
Downwards.
Downwards. So I'll call that IA.
Yeah.
So we are interested in the current through the 6 ohm resistor.
Yes.
Perfect. Okay. Okay. So already I can see some small simplifications that can be made.
Yes.
Because we are not connecting anything at the corners.
Correct.
Right. So those 6 ohm resistors are all in series.
Yes.
Right.
And we are not worried about voltages across those resistors.
Either.
So we can absorb, that node and make it vanish.
Combine them.
Okay.
Okay. So in fact, this looks simply like yeah. So I understand. So 6 ohms, 6 ohms, 6 ohms. We can draw it triangularly as well.
Yes.
We have made it a square.
Exactly.
Okay. Fine. So this is good. Actually, this looks like a problem which will become very easy with superposition.
Correct.
Because I can already see that there are, if I were to write the mesh equations, there will be 4
meshes,
variables, 4 meshes, 4 variables. It will take a long time to solve.
It will take a long time to solve.
Perfect. Okay. So let's solve this by superposition. So the first thing I am going to do is maybe because all the voltages are equal, let me at least mark the names.
Yeah.
So let me call them V1, V2 and V3.
V3. Right. So do you want to just redraw that simplified network?
But you know something?
Yeah.
Something is also striking me. I am wondering if suppose I de-energize 2 of them.
Yeah.
And I just energize 1 of them.
Yeah.
The circuit seems to look symmetric from 3 sides. This is just a wonder. I want to check at the end.
Yeah.
Whether the currents will be equal in each of the 3 de-energized cases. But we'll look.
But we'll look at it. Yeah.
Okay. So shall we just simplify the circuit?
Yeah.
So what I'm going to do, so A, B, C and D.
Yeah.
Okay. A and D. So I have 12 ohms.
Yes.
12 ohms here as well. So I have 12 ohms across each of those arms.
Yeah.
Okay. So A, B, C and D. And from the center, that is E,
yeah.
I have okay. So I have this voltage source.
Yeah.
This voltage source. Oops.
The other way.
The other way. So this is my 6 ohms
Yes.
and I want to find out IA.
Yeah.
Okay. So now this job, and this is E. So I don't know what the voltage at E is either. Okay. Okay. So, well, let us just start de-energizing one by one and see what happens.
Yeah.
So V1, V2 and V3.
Okay. So
right.
we'll keep only V1.
We'll keep only V1. So that's going to be my first step. So I have basically transformed my network like this. So now only V1.
Yes.
Is my first step. I need to short B and E, short E and C.
Yeah.
Right? Okay. So I am going to short V2 and V3.
Yeah.
So this was E, B and C.
Yes.
And I have
you have to retain V1.
I have to retain V1. I have 12 ohms here, that has to be retained.
Yeah.
Okay.
Yes.
Okay. And I have this one here and I have to retain this as well.
Yeah.
6, 12.
Yeah.
And I'm still, well, I'm going to call this current IA1.
Yeah.
That is IA1.
Perfect.
Okay. Now the first thing I'm already noticing
Yes.
is that this portion here, I have actually shorted out that 12 ohm resistor.
Exactly.
There is no current through that 12 ohm resistor.
Yes. So it's like putting a 0 volt source across those two.
Correct.
The voltage is fixed, current is fixed, and therefore that's out of the
picture. Right?
Right. Excellent.
So I have shorted. And I am also seeing that
you have shorted
6 ohms and 12 ohms are in parallel.
because you have shorted E and C.
I have shorted E and C. 6 ohms and 12 ohms are in parallel.
So yeah, so straight away we can redraw that.
So redraw this in a slightly different way. So well, I'll redraw it maybe like this.
Okay.
Which is easier for students to understand. Better to keep the topology the same.
We'll keep that topology first, and then we'll redraw it at the end when we bring it to the simplest form.
Perfect. So this BEC, we'll just call it E.
Yeah.
We'll just call it E. So I have an E here.
Yeah.
So I have 6 ohms and 12 ohms in parallel.
Yes.
So shall I just draw a resistance? 72?
72 by 18, 4 ohms.
18, 4 ohms.
Yeah.
Right. So basically I have 4 ohms.
Yeah.
So which is 6 in parallel with 12.
Yeah. Perfect.
Right. So let me D, A, B, E, C. Right.
Yeah.
So now let's call this D. I have just combined B, E and C.
Yeah.
Right. C.
Correct.
Right. Okay. Then I have between D and A.
You have a 12 ohm.
I have 12 ohms. So between A and E, I have 12 ohms.
Yes.
And between A and D, I also have the voltage source.
Something that we saw.
Something that we saw before. So I'll draw it outside because I have made it too small.
Yeah.
Okay. So this is V1.
V1.
Okay.
Right.
Interesting.
Exactly.
Interesting.
Right. So now what are we looking at? We are looking at.
We need IA1.
IA1.
That is hidden.
Yeah, that is hidden.
That is hidden.
That has got replaced by this 4 ohm.
Correct. And it is downwards, right?
Yes.
So we'll call this current
as
I1.
Yes, I1.
Right?
Perfect.
So the current flowing through the 4 ohm
yes.
Is the current I1.
Yeah.
That is combination of the current through the combination of IA1 and the current through 12 ohms.
Yes.
Okay, great.
Okay, great. Okay.
This seems relatively straightforward.
Yeah.
Because now I'm going to redraw it now.
Yes, yes.
Right. So now it's we'll redraw it. So this is V1, which is 12 volts.
12 volts.
And this is your 12 ohms in parallel with V1.
Yes.
Okay, we'll draw that as well.
Yeah.
and I have 4 ohms and 12 ohms
12 ohms.
in series.
Okay. Yes.
In series, I said this current flowing that way
Yeah.
is I1.
Yeah.
Right?
Right.
So, because let us not lose track of this. So, this is A, this is E,
Yeah.
right? A between A and
Where is D?
yeah. So, let me make sure I have not missed one resistance.
That is
D
between
is the
4 and
intermediate, this is the
intermediate
intermediate,
node.
this is D.
Perfect.
Okay. And I marked I1 as the current flowing through the 12 ohm from D to A.
Yeah.
Let us make sure we have got it. D to A, this is I1, correct.
Yeah. Okay.
Right?
Yes.
That is the right direction.
Right.
Okay. So, this seems relatively easy because between E and A I have 12 volts.
Yes.
So, this current I1 is simply 12
Divided by,
4 plus 12, 16.
yeah, 16.
Okay. And this is, we will keep it like this because we have to simplify.
Yes.
This I1 will now, maybe I will redraw it like this.
Slightly.
So, what I will do, I will redraw it with the rest of the network.
Yeah.
Now that we have redrawn it this way.
Yeah.
4 ohms, we got it by making 6 ohms and 12 ohms in parallel.
Yes.
So, what I am going to do, I will redraw it like this so that it will be very obvious what we are doing.
Correct.
We will keep the topology, the new topology the same. This is the original 12 ohm. So, we have let us say
6 ohms.
Yeah, 12 ohms and 6 ohms.
6 ohms. And the current through the 6 ohm is our
IA1. IA1, right? Correct.
Correct.
That is right. So, the current, this is IA1.
Yeah.
Because the direction is also in the same direction as what we have chosen I1 to be.
That is E to D.
Correct. So, this is I1,
Yeah.
right?
Right.
D to A and E to D,
Yeah.
right? So, this is E, this is A, this is
D.
right?
Perfect.
Perfect. Okay.
So we know that the current coming
This
into
current
this
coming in is 12 by 16 amperes.
amperes. Now we can apply your idea again.
Apply
So it
the
should
rule.
be
So, the rule is that the current through R1 depends on R2,
R2.
in the numerator,
Yeah.
right? So, IA1,
IA1 should be 6 by 6 plus 12.
oh sorry, IA1 will be 12
by 12 by 6
by
plus 12
12 plus 6
into,
times I1.
yeah,
So, this is actually 12 by 16,
16, right? Okay, great.
okay.
So it is 12 by 18.
Correct, 12 by 18. So, 12 by 18 is basically 2 by 3.
Yeah. So this is 2 by 3. Yes.
This is 3 by 4,
This is 3 by 4
right? So, this is basically half an
ampere.
ampere. Correct? Is this right? 144 by
seems like
16 into 18.
Yeah, yeah. Because
correct.
144 by 16.
288.
So, yeah.
16 into 18 is 288, I
Correct,
believe.
exactly.
So, it is half.
It is half.
Perfect. Okay.
Great. So we got one of the currents.
One of the currents.
Now what do we do for the rest?
So, now we did only V1 case.
Yes.
We need to do only V2,
Only V2.
right? So, let us redraw this only V2.
Yeah.
So, what I am going to do, I am going to make a copy of this.
Yes.
So that we have a starting point.
Yeah.
Okay. So, I will copy this. Okay. So, this is our starting point now, and we want to do only V2,
Yeah. Yes.
which means, okay, so we are going to short V1 and V3.
Yeah.
Okay. So, to make my job easier,
Yeah.
I am going to do this, I am going to retain this, but short V1 and V3. Is this correct?
Yes.
So, this was A. So, now A, E and C are shorted,
Yes.
okay, and this is now IA2.
IA2. Yes.
IA2 is the current I am interested in,
Okay.
okay.
Right.
So, this is the network gets transformed into this.
Yes.
Now, I am trying to see, okay, I have 6 ohms, 12 ohms, I have shorted this.
Yeah. So now A and C are shorted.
A and C are shorted,
So the network will just fold.
fold over, right?
Right? Yes.
Correct. So, in fact, these two arms, so these two arms and these two arms
Yes.
are in parallel.
So this is what we did in that equivalent resistance of the cube. We found
the cube.
equipotential points.
Correct.
And folded them, right?
That's right.
Exactly. So we should just do that.
Let us just
Right?
do that.
And redraw it.
Correct. So let us redraw it by folding it. So if I were to redraw this, I basically have, so let me draw the critical portion which we are not folding over, which is the center point.
Yes.
Okay. So this is basically V2,
6 ohms.
6 ohms. Okay. And basically I have between B and AEC node,
Yeah.
this is your I guess the compound AEC node.
AEC node.
This
right?
is B
Yeah.
and this is D.
D.
So between B and AEC I have 12 ohms on the left side,
Yes.
12 ohms on the right side, right?
Yes.
So basically I have 12 ohms on the left side and 12 ohms on the right side,
Yes.
right?
Correct.
And same thing on the bottom as well.
Bottom as well. So this is, yes.
12 on
12
both
ohms.
sides.
Yeah, let's write it down. Okay, great.
Okay.
So therefore now it's 12 and 12 in parallel.
12 and 12 in parallel. So this is 6 ohms, 6 ohms on the bottom as well.
Yes.
So now this becomes even more simplified. I basically have 6 ohms. So this is my V2
V2.
and I basically have 6 ohms. So
ohms.
this is my AEC
Yeah.
complex node, this is B
Yes.
and this is D. I have 6 ohms which is my 6 ohms
Yes.
that I am interested in the current
Interested in.
in. So this is
IA2.
IA2
Exactly.
and I also have 6 ohms here.
Coming from the parallel 12
So
ohms,
basically
12
we have combined this and this to
Yes.
create this 6 ohms
ohms. Yes.
and we have combined this and this to give us this 6 ohms.
Exactly.
They are just in parallel.
Exactly. Great.
Great. So, okay. This, now I see that this 6 ohms does not matter because it is in parallel with a voltage source V2,
Exactly.
right?
Yes.
So,
So what do we do now?
what do we do now? So, we are trying to find a current.
Yes.
Interestingly, let's redraw it. Right, let's
Exactly.
redraw it. So, let us figure out, this is turning out to be an interesting problem. So,
Maybe just make a copy of this there.
I'll make a
So
copy
that-
of this there, right? Maybe I'll draw it a little bit bigger because it might help to. So I have B. This is my AEC node.
Yes.
Okay, and this is my upper 6 ohms,
Yes.
and I'm okay. We'll just draw it the same way we drew it down there,
Yeah.
which is 6 ohms and 6 ohms.
Yes.
Now, one thing I can say that there is going to be a current flowing like this,
Yes.
which is going to be V2 is 12 volts. So, there is going to be a 2 amperes current flowing through, circulating
Yes.
here through the upper 6 ohm resistor.
Yes.
Okay. Now, my problem is what is the current flowing here?
Yes.
Okay. Now, I seem to note that there is a loop here which basically has no voltage sources and only resistors,
Yes.
right? Which means that the current flowing through one has to be equal to the current flowing through the other
Yeah.
with no voltage source. This is posing a problem. We have never seen this before,
Correct.
right? What do we do? So, in fact, let me redraw it so that people can understand. So, what is happening? So, if I were to redraw this,
Yeah. Just put the voltage.
I put
source
only
there.
the voltage source,
Yeah.
okay, and basically we have a situation like this, okay. I'm removing the other 6 ohms. We can draw it if we want or not, but basically for current to flow in any loop you need a potential difference,
Yes.
right? So, the only way that is possible is if this current is 0. There is no path for the current to flow,
Okay.
right? So, there is a potential difference between this node and here, right? And there is no, so this was B and this was AEC, So this was 12 volts.
Yes.
So the 12 volts AEC is at 12 volts with respect to B.
Yeah.
There is no current flowing in this loop. So this current is 0.
Yeah.
Right? Because current always requires a return path.
Yes.
If I were to connect these two, then there can be current flowing in this path.
Correct.
But now that there is no return path for the current, I can notice that there is no current flowing through the 6 ohm and the in the two 6 ohms.
In the two 6 ohms.
Okay?
Okay.
Because D is open circuit.
D is open circuit.
Yes.
Right. So,
Right? So the way another way to look at it, if I were to, because there are no sources, if I didn't want to use KVL, I can use KCL.
Yes.
So what I would do, I would, let's say this is D.
Yeah.
Clearly D is an open circuit looking downwards.
Yeah.
So there is no current flowing here.
Correct.
And which means there should be no current flowing here, because that is the current that has basically split through the two 6 ohm resistors.
Correct.
Any current flowing upwards
Yes.
from the 12 volts
Yeah.
can split as two and then combine back.
Yes.
There are various ways to look at it. Different people like to visualize it differently.
Yeah.
But clearly the current IA2 is 0
Is 0.
in this case.
Okay, excellent. So can you just go back to that initial picture, because
Yes.
I just want to see, could we have guessed this? Could we have guessed this, because we have with only V2.
Absolutely we could have.
Yeah.
Okay, because you could have just taken this picture and guessed it. The same way of redrawing could have been done with this. Okay, so if we take this, shall I copy it over to a new page?
Yes.
So if you just take this picture, actually what we have done, you can, since V2 is the only energizing element, if you were to combine these three into one node and redraw it, I would have redrawn it like this. So I have a voltage source between B and this AEC node, and so I had this 12 ohms and this 12 ohms, and I could have just pulled out, I could have just redrawn it like this with 3 arms, 12, 6 and 12, right, and I could have redrawn it the same way. So this is my composite AEC node, and we can know that the current entering splits into 3 arms and leaves.
3 combines.
If this current is 0, this current has to be 0.
Correct.
We could have guessed that this was your 6 ohms.
Yes.
12 ohms, 12 ohms. We could also have guessed, we didn't need to go through this redrawing. But maybe sometimes you, when you are practicing, you have to go through this process.
Yes,
right?
Exactly.
And then find out.
Absolutely. So, okay, good. So, this is a great problem, because we have encountered different concepts.
That's right.
In the 2 arms.
That's right.
So, let's look at the 3rd arm now. Maybe, I don't know if that has anything new to
Absolutely.
throw.
See, by the way, just wanted to say before we go ahead, this can be redrawn in many ways. So, for example, I could ask the question like this. This is exactly the same, right? So, I could have redrawn it, instead of vertically, I could have redrawn it horizontally. So, this is V, R1, R2 and R3. And if somebody asks you for the current through R3, for example, it is clearly 0.
There can be no current,
There
because
can
there
be
is
no
no
current.
return path.
There is no return path for the current.
Exactly. Okay, fantastic. So, let's now look at the 3rd arm.
3rd arm, right?
Because, by the way, you made a statement that the 3 voltage sources were symmetric.
Yes, it is clearly not symmetric.
It is not symmetric,
so,
right?
The whole idea is intuition can sometimes be wrong. Completely wrong. Right? So, you have to be very careful.
So, again, the idea is, when in doubt, we just go back to the basics.
Go back to the
basics.
basics.
Not make a mistake.
So, you start off with some possibility of intuition.
Yes.
You might find out that is wrong.
Yes.
Right?
Absolutely.
So, you have to be open to that. Never take a shortcut thinking that it's a shortcut, because it may be taking you a completely wrong path.
Exactly. Right? Yeah.
So, now our job is to do only V3.
Only V3.
Right?
Right.
So, I'll copy over the original, this my original circuit.
Yes.
Okay. This is my circuit. So, I am going to redraw it such that I only have V3 there. Okay. So, B is shorted to E
Yeah.
and to A.
Yes, V1 and V2 are gone.
V1 and V2 are gone. I have 12 ohms.
Yeah.
Okay, and this is E. Okay, so to C I have 12 ohms.
Yeah.
This is V3. So to D I have these three.
Yeah. 12, 6,
6 and 12.
12.
And this is IA3.
Yes, IA3. Now, at least are V1 and V3 symmetric?
Let's go back. It looks like if you look at the case with only V1,
V1.
okay, it looks like a mirror image actually.
It looks like a mirror image.
So instead of forming a composite BEC, you have formed a composite BEA
Yeah.
or BAE,
Yeah.
right? So this case at least should give me the same value.
Same answer.
Let's
right?
confirm it.
Yeah, let's confirm it.
Let's confirm
it. So we know what are we should expect 0.5 amps.
We should expect 0.5
amps.
amps, right?
Okay, great.
Okay. So by the way, so we should note down here that IA2 is 0,
Yeah,
right? That was our conclusion.
Yes.
And now we want to find out IA3. So now since BEA is a complex node,
Yes.
12 ohms is actually short circuit. This 12 ohms is short
It's gone.
circuited,
Yes.
right?
Yes.
And this 12 ohm is completely in parallel with V3,
Yes.
right? So now our job is kind of getting a little bit easier.
Yeah.
I basically have 6 and 12 in parallel here.
Yes.
Okay, so now I am slowly seeing where the circuit is coming from.
Yeah.
So maybe we can redraw it now.
Yeah.
So I'll first redraw it in the natural way, like this,
Yeah.
to some node. We have 12 ohms, right? So this is your complex node BE3,
BEA. Right?
BEA,
Yeah.
and across that you basically have this 12 ohm resistor.
Yes.
So this is P3, 12 ohms. So this is C, this is your BEA node.
Yeah.
I have removed the northwest 12 ohm resistor.
Yes.
And now I have 3 paths. So I have 12 and 6 in parallel,
Yes.
and then in series goes to D and then 12 ohms.
Yes.
So maybe I will show it like this. So this goes to D
Yeah.
and I have this arm.
Yes.
I have just redrawn it actually quite differently from the other case.
Correct. Yeah.
Right? And I am interested in this current.
Yes. IA3. Right.
Okay, so this is relatively easy to solve.
Yeah.
I know that there is going to be some current which is flowing here,
That is
but that is
independent.
of the rest of the network.
Correct.
Because it is in parallel.
Yeah.
The potential drop across BEA to C is always going to be V3,
V3.
which is
Correct.
12 volts.
Yes. Right.
Okay, so now I have to simplify this resistive network.
Yes.
So that's easy. So now I am going to call this I3.
Yeah.
Okay, so now let me simplify this portion of the network. So I have, this is 12 volts,
Yeah.
and I have 12 and 6 in parallel,
Yes. 12
which is
into
72 by 18, which is 4
ohms.
4 ohms.
Yeah.
And I basically have another 12 ohm here,
Yes. Perfect.
and this current is I3, right?
Yeah.
So I3 is clearly 12 by 16
Yeah.
amperes, and
We have the same.
IA3 to I3 or dependence also we know.
We know
from
it is
this
12 by 18.
it is 12 by 18.
18.
So 12 by 18 times 12 by 16. This is clearly 144 by 288.
Same thing,
right? So
0.5
this is
amps.
0.5.
Okay.
amperes.
So our guess this time was right.
This time was right.
Right?
Right.
Okay.
So let us see. So the total current, of course, IA
Yeah.
is IA1 plus IA2 plus IA3, which is 1 ampere.
It's just
Okay.
1 ampere.
So I think this taught us a lesson.
Yeah.
Right? It taught us a lesson that even though your original network looked somewhat symmetric, right? It is actually it seems like it is symmetric around this axis.
Yes.
Right? It is clearly not symmetric around this axis because on one side you have a voltage source, other side you have a resistor.
Exactly.
Right?
That is why V2 behave differently.
V2 behave differently.
Exactly.
Right?
Okay.
Great. So if I had actually swapped 6 ohms and V2 in some other network, you can now ask a question, right? Whether that current will be the same.
Same, exactly.
Right? Maybe we leave that as a homework for the students.
Exactly.
What happens if you swap the positions of V2 and the 6 ohm resistor?
Exactly, right. So, okay, so we have got now a 1 ampere current coming out of this
6 ohms.
flowing
through the
6 ohm in that particular direction, right?
Correct.
So, that means the potential difference VED is 6 volts.
VED is 6 volts.
Is 6 volts, right?
Correct.
And we know VEC, we know VEA, we know VEB.
Yes.
Right?
Yes.
So, I'm just trying to figure out, having derived this, is it possible to verify if this is correct?
I see. Got it. I understand what you're trying to do. So maybe VED was 6 volts, right?
Yes.
So let's write that down here.
Yeah.
So 6 volts.
Yeah.
Okay. Going from so this is 6 volts.
Yes.
Okay.
We know VEA, we know VEB, and then we know VEC because they are all just voltage sources.
Correct. Voltage sources.
Right.
Correct. And what did you want to do now?
I'm just trying to figure out, I mean, if I were to check, is this correct? Is this 1 ampere correct?
Is 1 ampere correct?
Correct, right?
Okay.
Are there any leads that we can sort of give the students?
Got it.
Here,
Got it.
right?
Let me see. Nothing really stands out for me.
Yeah, nothing really stands out other than solving KCL, KVL.
That's right.
So, yeah, well, sometimes you might just have to do that and double check the answers. Right?
Correct. But actually now that you have given me this thought, I mean, a reverse question can be posed, right? What should be the resistance such that this voltage should be 12 volts, because all the other 3 were 12 volts.
Yes.
Right? Students can think of, maybe we'll leave that as a homework.
Yeah.
But what I'm saying is, circuits people tend to think of such problems,
yes,
right?
Exactly.
So, because we saw the reason is, we saw that it was symmetric on 2 sides, but not symmetric on the other side.
Correct.
So, you can think of what will happen if you connect a 4th voltage source.
Yes.
Right? And then if you had a resistance to replace that voltage source, what will happen and so on.
What will happen and so on,
yes.
Right? Okay. So, yeah, that is a very interesting thought, right?